My name is Lindemann. I am the International Relations responsible at its OWL, and I'm very happy to give you a warm welcome also from our part to the event Industry 4.0 and Robotics, meet the Maersk Mc-Kinney Moller Institute and its OWL, who are both today's host. And yeah, as Morten has already mentioned, our goal today is just to get to know each other a little bit better, take a glimpse at our respective activities and learn more about our approaches to robotics, Industry 4.0, and also additive manufacturing. So we have a very interesting, exciting agenda for all of us prepared today. And at this point, I would also like to thank all of today's speakers for taking the time to present their labs and their activities, and especially also give a shout out to you, Morten. You have been a great support in organizing this event, so thank you. And yeah, this is already it in terms of welcoming remarks, and I would like to hand over to Mr. Günther Korda, who is the Managing Director of the German Technology Cluster, its OWL, Intelligent Technical Systems Ostwestfalen-Lippe. And he's going to talk a bit about our history, our strategy, our current lighthouse activities, and yeah, just give you an overview of who we are. And yeah, Günther, if you want to, you can now unmute yourself and I'll share the presentation. So the floor is yours.
Thank you so much, Salome. First of all, well, my name is Günther Korda, and I've got the big pleasure of being the managing director of this leading edge cluster, its OWL. And I know that you're pretty much interested in real projects, so I don't want to waste your time, just briefly guide you through who we are and how our development was. And then we hand over to those who are talking about real content. Okay, we are a pretty small region geographically, and we don't have that much inhabitants, just about 2.2 million in the meantime. But nevertheless, we are quite a strong region with regards to economic power, and we've got a high density of excellent universities and research institutions. And based on this specific structure, we created a clear strategy. And we had been a bit lucky. In 2011, federal government started a competition, and the idea was, is it worth to invest heavily into strong regions with the hope that they are becoming even stronger? And characteristically, for people in that area, they are not really that pushy in comparison to Bavarian people, for example, but they had been brave enough to say, okay, we've got so much powerful companies and so excellent knowledge and research companies, and if we combine those two capabilities, shouldn't we attend that competition? And guess what? Of course, we attended, and we finally were one of the winners, and we started in 2012 with a very specific profile. And as said before, we are pretty small, and if you are small and you want to create a strong strategy, then you need to stay focused. And so we concentrated on strengths which were around in universities and in respective companies in our region. And the idea was, we will focus on intelligent technical systems. Nowadays, people would phrase it to be enabling technology for Industry 4.0 or digitization. And these are just examples around harvesting, so systems which run autonomously, which are internet. Nowadays, we would phrase it IoT-based technology. But remember, the strategy was written in 2011. And of course, people interact with machines, for example, which not just creates acceptance, but which is definitely a decisive factor with whether customers will accept the products. And the final discipline is how to translate good technology or latest technology, cutting edge technology into robust, future-oriented product services. We're a technology-driven network, and we started with 46 different partners, out of which 80% were industrial leaders, hidden champions, easily within the top 5 in their respective market sectors globally. And we grew the cluster organization over time. And in the meantime, we've got 211 members. I just checked it this morning. But it's not our objective to simply grow. It's our idea to get better with each partner joining the cluster organization. And to the left-hand side, you see a number of quite successful companies. Many of them will not be known to you in your beautiful countries. Why? Because they don't have consumer products, and therefore they don't have such a high brand recognition. That may be different with Miele and Oetker, for example, but for many others, they are typical vendors to OEMs. And to the right-hand side, you see the universities and academic institutions, which have all competencies which you need to have if you want to create industrial applications, be it cognition systems, be it robotics, be it engineering, be it systems engineering or ICT knowledge. And this is nothing we created in the last years. This was around. We just needed to puzzle it together to come to really cutting edge applications. Next. And this is just a picture on a track record. When we started in 2012, when the competition was won, we wanted, for example, to do quite a large number of innovation projects, larger ones. Typical partners were 1 or 2 industrial partners and 2 to 3 scientific institutions. But a part of that, we wanted to do 120 transfer projects to small and very small companies. And all of you will know that the smaller companies get, the larger the gap to academian world gets. And we were not sure in the beginning whether we can achieve that. And I can tell you, we not just achieved that goal of 120, we overachieved it with 171 transfer projects run successfully with small and really very small companies. The smallest company was 7 employees, for example. And they cooperated with the University of Applied Sciences in Bielefeld. And I will skip the rest because that the documentation will be made available to you anyway. May I have the next one? This is just for information. This is these are the building blocks of our strategy. So we're an innovation-driven cluster. It's all about innovation, helping small and medium-sized companies to make larger steps in their innovation procedures, for example. And by joining forces, it should be possible that they gain an innovation leap instead of incremental minor innovation steps. And already mentioned digital transformation for companies, not just for mid-sized, but even for smaller companies with appropriate formats. And it's a lot about entrepreneurship. Already mentioned that we've got a number of hidden champions. So they would describe themselves to be, even today, entrepreneurial companies. And they are, even if they are pretty large. But we do have some shortage or lack of startups in our region. So we developed some formats attracting the attention of startups, whether they started their businesses in Tel Aviv or in Berlin or somewhere else in the world. And we bring them together with existing corporates having a strong need for innovation, which they can't develop organically fast enough. And in the end, it's about future of work. Which impact does latest technology or cutting edge technology have for employees and the organization of work? And that's something which we, for example, did together with the trade union, the IG Metall in our country. And this was quite clever because they will be invited to the table anyway. And if they will be invited, because that's law, given by law, then let's make them part of the project. And that's how we usually kind of orchestrate our projects, bring relevant partners to the table, let's bring them their ideas to the table, and then we deliver the right formats and make sure that they get the results they desperately need. And I don't want to give you too much explanation. It is just to give you a picture on what a typical innovation project is. It's a small company, 120 employees, and they did have the challenge. They wanted to increase their export business. Unfortunately, in Africa, for example, there's not such a job like a baker in Germany. And if there's one, then he does it as he thinks it's right that it should be done. And this definitely didn't help them in exporting their machines. So we implemented lots of artificial intelligence and methodologies to this machine so that regardless where it's positioned in the end, in which market, the final product is always of the same quality by identifying what is humidity, what is the quality of ingredients, so that the end product for consumers is as good as it would have been done in Germany. And we made a makeathon, and we awarded a team with €1 million funding for an idea which you have to put into reality within 1 year. And they fought 3 days in one go with another 30 teams. And we wanted 100 people to attend this competition, and more than 200 in the end joined. And we are so proud that this team not just did develop a very good idea, but they stay together and they are creating their own startup, and they're working on this project. And I think the last one, it's a lot about internationalization and getting access to know-how and skills. And we already knew in 2010 that the challenges of digitization will be that large that no single region will be able to have all necessary skills in their own geographically. So we started a benchmarking project and made a lot of regions around the globe visible to us. And so we did start some projects around IoT security, 5G and others, which you can see here. And we are more than open to cooperate with regions which are strong and open for cooperation. So I'm extremely curious to hear about the capabilities of our Danish friends. And that's it from my side. So happy that a number of people joined, and let's see where it leads us to. Thank you.
Okay, thank you so much, Günther, for your presentation. And now all of you have the opportunity to ask questions if you want to. Maybe Morten, you can help with the question.
Yes, there is actually a question, and the question is from Edvard Lorentzen from Teknikarbejdsgiverne. Go ahead, Edvard.
Yes, hello, my name is Edward. Which services do you offer for SMEs?
So we help them in finding the right partners to solve the challenges that they see. So bringing the right partners either along the value chain or academic partners to the table so that they can find all appropriate skills to work in projects successfully. And of course, we provide them with funding. So in the beginning, we had 40 million euro funding, which came from federal government. In the meantime, we receive another 53 million euro funding, which comes from the federal state of North Rhine-Westphalia. And these are things we are organizing, but in the end, it's about we are driving the whole process. And we try to be concise with our strategy. We develop a strategy documentation together with our most important partners, and then we try to figure out which are the right projects contributing the most to the challenges of the strategy.
Thank you.
Thank you.
Okay, thanks so much. Yeah, now I would like to welcome Mr. Christian Lindemann, who's the Managing Director of the Direct Manufacturing Research Center of Paderborn University, one of our partner universities at its OWL. And Yeah, Dr. Lindemann, we are curious to know more about the path from rollout to outer space, as you called your speech. And yeah, please feel free to share your screen now and fill us in on additive manufacturing. The floor is yours.
Thank you very much, Salome. Today it's about Industry 4.0 and robotics, and somewhere in between is what we do, which is called additive manufacturing. And yeah, as you said already, I called my speech for today "From the Road to Outer Space: Core Aspects of Additive Manufacturing, Digital Manufacturing from and for SMEs, especially in OWL." Yeah, DMRC is part of the technology landscape in OWL, and Mr. Korda has already talking about what kind of great technology region OWL is, and I'm really happy to be here, especially because of these many hidden champions, and OWL is especially a strong region in additive manufacturing as well. And why it is, I will tell you later on. So DMRC is called Direct Manufacturing Research Center, and was established in 2008 by the Boeing company. And it's basically an industry-driven research center. An industry-driven research center co-hosted by the Paderborn University. And companies came together to do pre-competitive research in terms of additive manufacturing, as the problems are mainly the same. There are many advantages of the technology, especially the great design freedom. But the problem is, or the general problem is, that the usage is mainly in research institutes and really technology leading companies. And the risks and possibilities are often unknown. And that's where we want to work on. And the aim of the DMRC is to develop this technology, to develop additive manufacturing towards an industry established production process in the terms of research, innovation, education. As a university, we are located in basic research. Due to the fact that we are internationally and company driven, we try to bring everything that we learn in our basic research into innovation, innovative product. As we can see here, it's a part from a telecommunication satellite. And furthermore, what we learn from our innovation and research project, we want to bring into education into the next generation of engineers who will use and work with all these new technologies and who need to have some solid background, because otherwise this technology is not going to be used at all. Who's part of this effort? So we've got from the research side, the Paderborn University, and over here it's not only one chair, but it's pretty much 3 faculties already and 12 different professors doing research depending on the problem. So we can go from IT topics down to material science, design, we got economic science included, and so depending on which problem we want to tackle or which challenge we get from the industry, we will find the right consortium here at the Paderborn University. Furthermore, we have some of the companies paying an annual fee to be a member of the DMRC. And over here, we got the complete value chain from the design and materials, for example, with Evonik, EOS, BASF. We got the production side, EOS, SLM, and furthermore. And we got a couple of service providers and end users, from the big ones, as you might know, as Porsche, John Deere, but we got a lot of local companies as well, for example, like Krause Dimatec from Bielefeld, Protek, Stücker Jürgen, Centroplast or Rembe as well. So it's quite of an interesting mixture of locally SMEs and international leading companies who come together over here. Mr. Korda is talking about startups, and we've got 4 startups already. I've listed 3 here, dealing with simulation, part marking, or other things, and we are active in a lot of different networks to participate. Yes, in summary, we are 23 industry members, 12 chairs, around about 33 PhD candidates, 100 students, and we have around about 22 industrial AM machines, and which we put in as an effort to drive forward additive manufacturing. So where's additive manufacturing in the context of Industry 4.0? I've looked up this this definition by the Boston Consulting Group that 9 main Industry 4.0 technologies. The typical ones: augmented reality, big data and analytics, autonomous robots, simulation, horizontal and vertical system integration. We got the Internet of Things, cyber security, the cloud. And one of these 9 technologies is said to be additive manufacturing as well, which is enabling the digital production process. So yeah, in general, smart manufacturing is supposed to drive the automation of manufacturing processes. And how smart additive manufacturing is and how it fits into Industry 4.0, we'll see later on based on a couple of products. So the main question is, first of all, what is additive manufacturing? What is 3D printing? And yeah, in this world, there's many 3D printers. Over here, unfortunately, this is a German cartoon, but he can say, hey, I cannot believe it. You're having a 3D printer at home. And he sees these nice 3Ds on the print. And pretty much everyone has a 3D printer at home, as you can see. Furthermore, that's one of the things I like the best. The father comes to his son and shows him a floppy disk. I guess most of you will still know a floppy disk and how you formatted them. And the son, he's a complete different generation, and this is the generation of the future of Industry 4.0. And he just says, wow, cool, you made a 3D model of the save icon. For him, 3D printing is completely normal, but he doesn't know about physical storage anymore. So there's a clash of generations. Some furthermore, as you can print houses in the future, and there will be saloons or print shops where everybody will go in the near future. So what I often hear, I know 3D printing. My neighbor's child has a 3D printer in his room and they're playing with it. That's right, but there's more about placings for 3D printing. So we got at the Paderborn University quite a wide diversity of this technology, from polymers, metals, and powder polymers, metals with powder, and other polymer technologies. So additive manufacturing in general is a quite variety of technologies already, and here at the Paderborn University we have most important technologies, and we are as well able to produce base materials for it. So we got a powder tower and a cryogenic mill for the polymer powders. We got a mill for the metal powders. We got a filament extrusion line for the filament processes, and most of these machines cost around about $500,000. So these will never be in a child's room, and if they would be, I would be happy to be that child. Yeah, so there's quite a range of technologies, and I never like it so much that 3D printing is thrown in one pot. I always compare it to an orchestra, like the same with the production technologies. 3D printing is a multi-faceted technology, and you need to combine the different technologies you have. So the 3D printing technologies together with traditional technologies, and these need to be connected digitally, so that this is going to drive the environment of Industry 4.0. So, come on. Yes. Additive manufacturing and Industry 4.0 is a trend topic in the media, talking about third, fourth industrial revolution. We got it on the racetrack. People want to build moon bases with additive manufacturing. And actually, we've applied for this project. We didn't get it, but a lot of things are going to happen. Some of my favorite things are orthesis, prosthesis. So the medical sector, additive manufacturing will do big things for everyone. Yes. In total, we're looking for a factory that can bring out a variety of different products each day, depending on the customer specification, and a very flexible digitized company. We just give in your CAD data, and additive manufacturing will be one major milestone on the way to such factories when embedded completely in the Industry 4.0 technology. Yes, so the question is, what about the technological maturity that we are having? This is one company, the Gartner company, and they are publishing the Gartner Hype Cycle each year. And we see that additive manufacturing had quite a development over the past years. So, for example, in 2000, let's explain first the Gartner hype cycle. Those as the technology trigger. When there's a new technology, then you got a peak where you think this technology will save the world, and then at some point you realize it cannot. And after this point, you come to the slope of enlightenment, and later on we'll end up at the plateau of productivity, where such a new technology will have a certain maturity that will be used. So 3D printing in 2011 was here, moved up to the peak real fast. 2013, 14. They divided it in consumer 3D printing and enterprise 3D printing because it's two completely different things. And right now they decided to bring out a complete new hype cycle, which is only dealing with additive manufacturing in the different areas. So consumer 3D printing, manufacturing operations, 3D printing supply chain, surgical implants, and so on and so on. Classroom 3D printing. So more and more schools are coming to us asking for education programs and to help them set up 3D printing at the schools. That's things we do as well in terms of education, and where we're always happy to help out. Yes, additive manufacturing is very versatile, and so are the different degrees of maturity. The technology readiness level are different for each application, basically. So, it's a question that I always get, is it all just a hype? 3 facts about the status of additive manufacturing or additive production. And going to go a little bit in here. So fact 1 is additive manufacturing is already in serious production. Not too many, but it's already working. So we got mascara, eyeliners, we got other things. Right here, one of the pioneers was Adidas, which brought out a 3D printed shoe in its Speed Factory. And when Adidas brings out something on the market, then you need to be quite sure that it works. Yeah, and GE has invested a lot of money in this technology and built a factory just to build this one fuel nozzle over here, which was economically quite successful. And as well, Audi and all the other automotive companies are working on it. And over here, there was a project where they wanted to bring a rover to the moon. And they wanted to be, or have the first Audi on the moon. And they worked together with a team of scientists who wanted to have the first private financed rocket on the moon. And the science, or the slogan was, hell yeah, it's rocket science. And over here, especially the wheels have been manufactured by SLM Solutions for this Audi Moon rover, where we have the gap to the robots again. And if you have a look at the patent applications in the past years, that's one of the things that you can see here pretty well, is that the main Industry 4.0 technology patent applications are shown here from 2010 to 2015. And cloud computing and augmented reality were quite big all the time. And but the patent applications for 3D printing started to explode around about 2012. That's what I can say about the market as well. Since 2012, 2013, the market explodes and it's growing rapidly. And big data and 3D printing are the big newcomers in terms of patent applications. And you see that this topic is very trending over here. As well, the market is in place and it will grow. The forecasts are quite big. This is only for polymers and composites. And you have growth rate of the markets from 22, 23, 25% each couple of years. So it's quite a huge growth rate when investing into the technology. Yes, now I want to talk a little bit more about applications made in Ostwestfalen-Lippe, as our nice region is called, and applications made by Mittelstand, by SMEs. Mittelstand, that's such a typical thing, I guess, as well for this region, as well for Germany, which makes us strong, which is the backbone of our economy, in my understanding. So first of all, Ostwestfalen-Lippe is a key region for additive manufacturing in Germany, and we are just about to start an initiative for networking of additive manufacturing in this region and beyond. So we started with 3 companies: Additive Marking, Condor Custom Solutions, and the DMRC. So this is quite a young network. It has not launched yet. We're in the building phase. And these are just 3 of the many companies which are active in OVL. And as you can see over here, it's quite a bit. We have in the region Emendate, one of the spin-offs, Centroplast, BMG Mori, producing machines in Bielefeld, Improved. The University of Science in Ostwestfalen-Lippe, we got Blue Production, H&H, Krause Dimatec, Stücker-Jürgen Aerospace, Protic, and the Paderborn University. And there's quite a lot going on, what many people also don't know. We want to change this, and we will launch a webinar series about AM in OVL very soon. And the kickoff will be the 1st of December in 2020, and you can have a look at this website and stay informed if you want to join deeper. So we call it from Mittelstand, for Mittelstand, and there will be presentations by the companies, by users, and by university, going deeper into the technology and explaining the backgrounds. Yeah, but we want to see what does actually AM actually change the product design. Why are we so successful? Physical effects cannot be influenced, will never be. The main thing is the geometry. Throughout additive manufacturing, you can create a geometry freedom, and you got completely new design possibilities. And especially in terms of materials, you can change different things. We got the possibility of graded materials. So that we got one material with different, material properties in different areas, and new material combinations are possible. For example, iron, silver together, which would not be possible in a different way through the special process characteristics. And what we are doing with these material combinations is, for example, biodegradable implants. Furthermore, through the combination of special geometries and different materials, we can come to the implementation of new active principles, so that you can have new geometries, for example, to do some active cooling or cooling principles or other things like dampening or so on or so on. So can we have smart products with semi-smart manufacturing with additive? So I just want to give you a couple of examples of smart products which are smart in my understanding. This is, for example, injection molds where you can have inner cooling channels, and we have cycle time reductions up to 44%. Right over here, we have an example from Protic, one of the daughter companies of Phoenix Contact. And you can have improved functionality, as we had over here with the example of aquarium wheel pump. And this was the original design, and they always had problems with counterfeits from China. And then we did a redesign. We increased the efficiency by a factor of 5, due to the problem that you need such a machine, you need the parameters, you need to know about the material. There were no counterfeits of this product on the market afterwards anymore. So that's kind of smart for me. Decreased size, increased functionality, no counterfeits anymore. So then we did a little bit test with dampening. So we built lattice structures in parts and left some powder in there, which functioned as a particle damper, which is especially interesting for the automotive industry. When you think about e-mobility and you don't have the sound of the engine anymore, you need to manage different sounds, different vibrations that you need to get out, because you hear a lot more what is going on in the car. And you can have integrated component markings as a basis for traceability, and the connection to the digital twin is very, very important nowadays. And these can be visible or invisible, that you can probably only see them on a CT scan, or you can have them on the product automated, and you can scan them with a QR code. And these are things you can integrate direct when you are in the production. So, is 3D printing now very smart? We will see about that. So we will discuss it with a couple of solutions from OWL. So first of all, the presentation is called From the Road to Outer Space. And we are doing space research here in our region as well. We had a project with ESA, and the ESA wanted to see which parts of a telecommunication satellite may be printed, and where we have a big challenge of improvement. And then we had this one part, it's a reaction wheel bracket. There's 3 on the satellite, and there's a reaction wheel, and over this reaction wheel, the satellite may change its position in space. we went into the redesign and we asked them, okay, for 1 kilo weight saving, how much money do you save? What could we spend more? And they said 20,000 euros per 1 kilo. And why is that? That's because they can bring more technology, more payload on the satellite. And they said, okay, we think we can have that. And what you can see over here is that AM, or that we did a topology optimization, having a look at the design space, the non-design space, bringing it into the intersection, going to the optimization, smooth and remove the details, and come to a final part. And these things have been possible before, but before you were not able to manufacture these things. So AM is an enabler for topology optimization in these cases. And software will become more important and contribute to the terms of industrialization. So now we were here, and so far the whole product development has been digital. Now there's a question how much Industry 4.0 is in this technology, and where do we need to continue working. This is Thomas. Thomas has designed that part, and he's one of the guys who has a startup now. And we got the digital production, and the part comes out, and so far there was no real manual work included. But afterwards, that's where the sorrows start. There's the manual working. Now you get individualized parts that you need to post-process, as the surfaces are not always best when coming out of the machine. Over here you can see, by the way, one of these integrated markings of the part which have been included in here, which you cannot see. Yes, and that's where we need to start working. Automation and post-processing currently is rather Industry 1.0 than Industry 4.0. And we have to consider this through the whole process chain. Nevertheless, we had some really good results. So we were able to remove the weight by 60%. We were able to increase the stiffness and the eigenfrequency. But is everything new? I say no. I had a look at one of my old design scripts from, I think, 1980 or so. And it showed that you could always remove or decrease the number of parts. You could always do smart design to reduce costs. And now we get a lot of more possibilities to do that. On the economical side, our production costs were reduced by 53% for this example. And if we calculate it with these values given by the ESA, there was quite a big decrease in life cycle costs. And there's another real advantage is the earlier availability of the part and that we had more payload. Need to hurry up a bit. So I don't know if anyone knows what this part is here. It's called a Stüpfler, and everybody of you probably gets in touch with some of the products of here each day. It's a highly industrial production, as you can see in this machine here. It's a very high output rate, a couple of thousands a minute. And what does it produce? So this one is 3D printed. It's 3D printed on a standard part, which has been manufactured traditionally, and the more complex geometry will be built by additive manufacturing on top.